In this episode, we take the phrase deep learning and turn it into something you can explain calmly, because deep learning is one of the most overhyped terms in AI and one of the most intimidating for beginners. People throw it around as if it automatically means the system is smarter, safer, or more advanced, and that can cause two different problems. One problem is hype, where people treat deep learning as proof of quality without asking for evidence. The other problem is math panic, where new learners assume they must understand complex equations to even talk about it. For an audit-focused certification, neither reaction helps, because what you need is an honest, practical explanation that supports good questions and good oversight. Deep learning is not magic, and it is not a marketing badge. It is a particular way of building models that can learn complex patterns when given enough data and computing. Once you can describe it clearly, you can also describe what it changes for risk and controls, which is exactly what an auditor needs to do. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A plain language definition is that deep learning is a kind of machine learning, ML, that uses many layers of processing to learn patterns in data. The word deep refers to the number of layers, not to the idea that it is mysterious or profound. You can picture it as a stack of pattern detectors, where early layers learn simple features and later layers combine those features into more complex ones. For example, in an image task, early layers might detect edges or textures, while later layers might detect shapes or object parts, and still later layers might detect whole objects. You do not need to know how the layers are calculated to understand the audit-relevant idea. Deep learning can automatically learn useful representations of data, which can make it powerful for complex inputs like images, audio, and language. This power is why organizations use it. But power also increases the need for careful oversight because it can be hard to explain and can behave unpredictably outside its training conditions. That balance between capability and oversight is the heart of deep learning in an audit context. It helps to contrast deep learning with simpler approaches without turning it into a technical debate. In many traditional ML methods, humans decide which features to feed the model, like choosing average purchase amount or number of logins. Deep learning can reduce the need for manual feature design, especially for unstructured data like free text, images, and sound. Instead of handcrafting features, the deep learning model learns features as part of training, which can be a major advantage when patterns are subtle or too complex for humans to design. The trade-off is that the learned features are often not intuitive, which can reduce explainability. For an auditor, this means you may rely more on documented testing, monitoring, and governance controls rather than on being able to interpret the model's internal logic. It also means changes to data and context can have surprising effects, because the model may be sensitive to patterns humans would not notice. Deep learning is therefore not automatically better. It is better for certain kinds of problems, and it requires disciplined validation and oversight. Now let's talk about why deep learning shows up so often in conversations about modern AI systems, including systems that generate text or analyze language. Deep learning models can learn relationships across sequences, like the way words relate to each other in a sentence, or the way frames relate to each other in a video. This ability to capture complex relationships is what makes them useful for tasks like translation, summarization, speech recognition, image classification, and content generation. For beginners, the important point is that deep learning often thrives when there is a lot of data and when the patterns are complex. It is less about being universally superior and more about being suited to certain data types and certain complexity levels. From an audit angle, this means deep learning systems often involve large datasets, heavy computing, and complex development pipelines. Those factors create risks related to data governance, privacy, and operational control, because bigger systems can be harder to manage and harder to fully understand. The exam may not ask you to describe the architecture, but it may expect you to recognize that deep learning implies complexity and therefore raises the importance of strong governance. A key term that often appears alongside deep learning is neural network, which you can explain as a model structure inspired loosely by how brains process information, but implemented in software as connected layers of calculations. The inspiration story is interesting, but for auditing, the useful idea is that neural networks learn by adjusting internal parameters during training until the outputs match desired targets as well as possible. That adjustment process can create very large numbers of parameters, which is part of why deep learning can model complex patterns, but also part of why it can feel opaque. Another term you may hear is training, which is the process of feeding many examples through the network and updating it based on error. Another is generalization, which means the model works well on new data, not just the examples it saw during training. These terms matter because deep learning can sometimes memorize patterns in training data without truly generalizing, especially when the system is too flexible for the amount or diversity of data available. In audit language, that risk connects to whether testing was realistic, whether performance was measured in appropriate ways, and whether the organization understands the model's limitations. One of the most important deep learning risks to understand is the gap between impressive performance in a controlled setting and reliable performance in real-world conditions. Deep learning models can be sensitive to small changes in input data that humans might not notice, such as lighting changes in images, background noise in audio, or subtle shifts in language usage. This is not always a flaw. It is a reality of pattern learning, and it becomes a governance issue when organizations assume reliability without monitoring. Auditors care because the controls must account for this sensitivity, especially when the system affects safety, fairness, or critical decisions. A model that works well on a benchmark dataset might behave poorly in a different environment, and the audit question becomes whether the organization tested under conditions that match production. Another audit question is whether monitoring exists to detect drift and performance degradation over time. Deep learning can be very capable, but capability does not remove the need for disciplined validation and ongoing oversight. In fact, capability can increase reliance, which increases the harm if the system fails silently. Explainability becomes especially important with deep learning because the internal reasoning is often hard to translate into simple human explanations. That does not mean deep learning is unusable in high-impact contexts, but it does mean the organization must plan for how decisions will be justified and challenged. Sometimes explainability is handled by using additional tools or methods to highlight which inputs influenced an output, but as an auditor, you focus on whether the organization has a clear approach, not on the technical details of the method. You also focus on whether the approach is adequate for the risk level of the use case. For example, a recommendation engine for entertainment content may not require the same level of explanation as a system that affects employment or access to services. The audit question is whether the organization matched explainability practices to impact and whether it can produce evidence to support its decisions. If the system cannot be meaningfully explained, then the governance must compensate with stronger testing, monitoring, and human review where appropriate. Deep learning does not eliminate accountability. It challenges the organization to demonstrate accountability through other controls. Another audit-relevant issue is data privacy and confidentiality, because deep learning often uses large datasets that may include sensitive information. If training data includes personal information, the organization must control access, ensure lawful and ethical use, and minimize unnecessary exposure. Deep learning models can sometimes retain information from training data in ways that are not obvious, which creates concerns about whether sensitive data could be revealed through outputs or model behavior. You do not need to master the technical mechanics of that retention to understand the audit question. What data was used, who approved its use, how was it protected, and what safeguards exist to prevent leakage. This connects to governance practices like data classification, access management, and documented data handling processes. It also connects to lifecycle management because training data may be refreshed over time, and each refresh is a new risk moment. Deep learning makes data governance even more central because the scale and complexity can make mistakes harder to detect and correct. On the exam, deep learning scenarios may reward answers that emphasize disciplined data controls and clear documentation of data sources and permissions. Deep learning also tends to increase operational complexity which can create reliability and availability risks beyond the model itself. These systems may depend on specialized infrastructure, large compute resources, and complex deployment pipelines. Operational complexity matters to auditors because it increases the chances of misconfiguration, weak change management, and inconsistent versions in different environments. It also raises questions about resilience, such as what happens if the model service fails, how fallbacks are handled, and how updates are controlled and tested. Beginners often think audits only focus on ethical concerns, but operational concerns are equally important because outages and performance failures can create direct harm. An AI model that is correct but unavailable can still disrupt business processes. An AI model that is updated without proper controls can introduce new errors or fairness issues. Deep learning systems can be harder to roll back and harder to compare across versions because small changes can have large behavioral effects. That is why governance and monitoring practices become critical parts of responsible use. To keep your understanding practical, it helps to separate what deep learning changes from what it does not change. It changes the typical level of complexity, the reliance on large datasets, and the difficulty of explaining internal reasoning. It often increases the importance of rigorous testing, realistic validation, and continuous monitoring. It does not change the basic audit workflow, which still begins with understanding the use case, verifying requirements, evaluating controls, and checking ongoing oversight. It also does not change the core idea that outputs should be treated as estimates and that decision processes must be governed. Deep learning may produce very convincing outputs, especially in language-related systems, and that can tempt people to treat outputs as authoritative. From an audit standpoint, that temptation is a risk, and controls should address it with clear guidance on appropriate use, human review where needed, and documented limitations. The exam may test whether you recognize that deep learning's confidence can be misleading when outputs sound fluent or look polished. Your answer should reflect caution grounded in evidence and governance, not fear and not hype. A beginner-friendly way to evaluate deep learning claims is to focus on 3 questions that always matter. First, what is the system used for, and what is the impact if it is wrong? Second, what evidence shows it was tested appropriately for that use case, including realistic data and defined thresholds? Third, what oversight exists after deployment, including monitoring, escalation, and accountability for changes? These questions do not require math, but they do require discipline, because stakeholders often jump to benefits without documenting constraints and failure modes. Deep learning does not remove the need for those questions. It increases the need because complexity can hide issues. When you see a scenario that mentions deep learning, it is often a signal that explainability and monitoring may be challenges, and that governance must be strong enough to manage those challenges. You can then choose exam answers that emphasize documentation, validation, monitoring, and appropriate human oversight rather than answers that rely on trust and sophistication. As we close, the main thing you should carry forward is that deep learning is simply a powerful approach within ML that uses many layers to learn complex patterns, especially in unstructured data like language and images. It can deliver strong performance, but it often reduces transparency and increases operational and governance demands. The audit mindset is not to fear it and not to worship it, but to evaluate it with clear questions about data, testing, oversight, and impact. When you can describe deep learning in plain language, you can also resist buzzword shortcuts and focus on the evidence that proves the system is appropriate for its use case. In the next episode, we will break down training, validation, and inference even more explicitly, because those lifecycle stages are where many audit questions live. For now, remember the anchor. Deep learning is not magic. It is layered pattern learning, and the responsible way to use it is to pair its capabilities with strong governance, realistic validation, and continuous monitoring.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.